Hello, and welcome to this plant engineering video conversation. I'm your host, Amara Rasgus, and I've connected with Michael Wrinch from Hedgehog Technologies. This is part of the Maintaining Your Plant Floor Edge series, which focuses on maintenance from a lot of different angles. So thanks for joining me today, Michael.
Well, thank you for having me.
Awesome, awesome. So here's a little bit of background about my guest. Dr. Michael Wrinch is the founder of Hedgehog Technologies, an electromechanical engineering firm with more than 20 years of solving complex problems in manufacturing and in plants. Michael serves on the board for Technical Safety BC and Engineers Canada to promote safety in the industry. So I'm happy we're talking today, and it sounds like we have a whole lot to talk about. Let me get right to this very first question I have. So, what's the current trend in maintenance for industrial and manufacturing facilities?
Okay, great. This is a fun topic. We're going to go all over the place on this, so you may have to reel me in here. But I'm going to say first is because this comes up all the time is no one's losing their jobs. This we play with all kinds of technology and all kinds of advancements, and what we're finding is the new technology that's coming in. Everyone wants to talk about AI, and we can talk about that later. But really, all it's doing is enabling us to make better decisions and allow us to run our plants better and for everyone to do their jobs better. But the scene where like you hear about control, AI-based control and AI-based decisions, and people won't need to be there. That doesn't happen at all. It's just you need to develop a different. All of us need to develop slightly different skill set, but we're not losing our jobs. But really, like, what is the trends that are coming into? And really, it depends where you are at, where your factory is at. For example, if you're producing millions of dollars of product a day, or you're producing thousands of dollars of product a day, it's a slightly different question of where you're at. But generally speaking, everyone is big on collecting data to make data-based decisions. So I'll call it, I'll use the word in the olden days, which was not very long ago. Uh, what we do on the plant floor is you have some really experienced plant managers and maintenance team and operations team, and we make judgment calls on the floor on when things should be changed, when things should be maintained. And the team are really well trained and they're quick to react. And something goes down and it's either quickly fixed. If you have long-term experience in the plant, people will make decisions based on when things should be replaced. That's sort of what we've seen is in the old way. Some smaller factories will run things to failure, and then when they fail, everyone gets together and it's quickly repaired as quickly as possible. So there is some predictive work and some real time. Let's just run things to failure and then fix them. So that's the two things that are going on. But now, with collecting big data or just collecting data, you can start making decisions based on so collecting data and adding advanced sensors. So there you can add, say, for example, on motors, we used to see things like some vibration sensors, but you can have vibration, thermal, audio. There's all kinds of current patterns, and then adding that together and looking at what is the performance of this motor, or the signature of good, and what is the signature of bad. And then the next time that happens, you can start making better decisions and start guessing when it's going to happen. Oh, this motor is going to go down within the next 30 days, this motor is going to fail. Can you say within the next 3 days, this motor is going to fail? And then you can start planning for that. So that's where we're seeing a big trend and a lot of change happening there.
Well, you talked about a couple different strategies here, Michael. When you're considering your most effective maintenance strategies, what are some of the advantages?
Well, I'll tell you that my favorite advantage of this is, okay. There's the basic advantages that we can say, like you have increased equipment uptime. You can save money. Your equipment will last longer. The equipment is safer, and you can make, the important one is database decisions. I mean, that's kind of the easy things to say, but what does that really mean, in a production facility? Well, for the big factories we're working, like this one picture in the background here, these guys are making millions of dollars of product a day. And if something goes down, they said their prediction on cost is about $50,000 a minute when they're down. So what's the cost of a piece of equipment on a main line on a high production day, something going down unexpectedly? That is bad. And so they're really keen on finding ways to get to ensuring that when they're in production mode, everything is running and nothing goes down. So they're spending a lot of money on, not just, we used to do thermal sensors, like just looking for the temperature, but now there's thermal cameras. So you can look at the picture of a motor running or some bearings. You can look at the thermal signature of bearings, not just are they hot or cold, but how are they hot and cold? And we can ask those questions. And so that now on the factory floor, opposed to becoming a cost center, which is what we always get blamed for, is we always spend too much money, and people say, oh, the engineers or the maintenance staff are always trying to spend money, and the decision makers that give us the money are really trying to maximize their profits. But with the database decisions now, we can say from the data we have and the analysis we've done, this machine has 3 days left in it, or this gearbox may have 3 days. It's not like, oh, it's between 3 days and 4 months, and then everyone wants to just run it till it fails, because that's too expensive to replace a part that with that amount of variance. But if you could say we have days to hours before a part fails, or we can say, within the next month that's going to fail, we should start planning a capital project to replace this part, then we become a source of a profit, really, because the decision makers who fund these projects can see that we can find ways to make them more money by preventing these failures from happening.
So we just talked about technologies, capital costs, all that kind of stuff. Thinking about people, what do you do, or how do you ensure effective communication between the maintenance team, other departments? I mean, let's look at this from a people standpoint.
Well, I'm glad you asked that too, because it really is a people problem. In fact, one of the biggest mistakes I've seen is you've got let's simplify this to 2 groups. There's the capital projects group and there's the operations group. And capital projects groups are pulling out machines and upgrading everything. And then there's an operations group that's got to deal with whatever this capital project group has done. And sometimes they're the same people, and sometimes some of them are the same people, but it's usually not all the same people. And the word I like to use is, if you have not operationalized your upgrade, you're simply, the upgrade's going to be a waste. I'll give you an example. Is we had to do a major upgrade on a facility. We were putting in these 1 megawatt variable frequency drives, these are huge motor drives, and we had to do a major upgrade, and we didn't know if the facility had enough electricity. Like, did we have to contact the utility and do an upgrade for this service of how many amps the plant could get? And so we were trying to find that out, and we looked, and there's all these power meters all over the facility, and we said, oh, that's great. Where's the data? Well, what happened is there's some computer somewhere in the building, no one even remembered where it was, is logging the data. So we did a what's called a data sniffer. So we were trying to sniff out where they were logging data somewhere, but no one could find the computer in this facility where it was going. And in the end, they actually just gave up. We just said we don't know where it is, and if it's going somewhere, we certainly don't know how to access it. So that's an example of someone spent a lot of money 10 years earlier, and it wasn't properly operationalized. And these things log this data for all this years. It was never upgraded. It was never maintained. And then when we need it, it wasn't there. And we had to redo. So what we ended up having to do is our team came in and had to write a program to extract information from these power meters and relog data for another 2 months. It was there. Just, I mean, they had the meters in, but they just didn't have any way of reading it properly. So we went through all that cost to re-operationalize something that should have been done years ago. And that's example of you have technology, you put it in, everyone at the time agrees it's really useful, but that's a capital project. But then they didn't say, okay, operations folk, we need to help you understand how this is useful, and there's a maintenance schedule with this technology that someone has to be responsible for and own it. And then the future you will thank yourself for maintaining it and making sure that it's kept up to date in a way that works for everyone. So that's an example of how important it is to operationalize and properly train the people that are there using the equipment. And hopefully I'm not repeating myself here, but it really is, once a project's done or started or initiated, the capital projects people need to engage the operations team about how this is going to work. How is their workflow going to look and change, and start the change management process early so that it doesn't land and everyone just fights to go to the old ways. That happens a lot too. You put some fancy equipment in, but everyone just really wants to do what they did before because the change management, humans don't like to change quick. So you throw something down that's too much of a change, they're just going to fight to go to the old way and insist that the old way is better. And we've seen that as well. So we're really keen on working with the plant operations and capitals people to ensure that everyone's on the same page, so that you end up with a successful project, the long-term sustainability of the project. You come back 5 years and everyone is better for it, not just abandoned a bunch of fancy equipment.
Right. Well, speaking of the old way, we have some new ways to do things. So what role do you see things like predictive, preventive, or even prescriptive maintenance play? I mean, is that a good thing? Is that a cost-effective thing? What's your take?
Well, okay, that's a great example. That's a good one. It works and it doesn't work. And I'm sure anyone who's been working in this industry will agree with me. It works and it doesn't work. A good example is, I think Rockwell, they have in their drives, there's some predictive tools in there that'll tell you that you've got to prescribe when to replace things, and you can, but we almost always disable that because it just isn't correct for the application. I mean, it's a generalized system, but what the operations team needs to do is saying, how can we train this tool for our plant, our utilization? And then these tools start to become really useful. So you can say at the beginning, you're going to say, we don't have data to support how this is going to work, but the training of this equipment, so it can start helping us guess, has to start now. And then in a year from now, we can reassess how that's working. And then if it says to replace something, you still need your skilled floor people and operations group to say, does that even make sense? You still need, in my opinion, you still need professional judgment in the system. And this is where I was saying, no one's going to lose their jobs. These tools will offer you deeper insight on how your equipment is running and how well it's running, but it won't replace that critical decision of, are we going to pull this system offline and fix it now, or should we pull off this part and fix it, plan to fix it later? So there's this, the predictive nature only works when you have application specific data to support it, and the training and the professional judgment to help it learn how that's going to work.
I love that sentence or that phrase that you just said, no one's going to lose their jobs. Fantastic.
Yeah.
Thank you. But we have to think about artificial intelligence and machine learning and all that new technology. You know, where does that come in? Is that going to hurt? Is that going to help?
Yeah. So I've seen all kinds of, I mean, everyone's trying to find ways to make it work, and finding ways to see if you can get AI in the loop. But AI only works if it has the right data to train from. So if your factory doesn't have a good historian or data logging system or a history of information, your AI is simply not, the AI just simply won't work, because it's only trained on the past. It can't look forward unless it knows. It's like a human, right? It's got to learn. It needs to learn from what's normal. And if it doesn't know what normal is, it can't run. So you really need to say, where are we as a plant? Like, how is our operations working right now? Do we have the right system in place? Do we have the foundation? Is our system properly logging? Are we sensing the right things? Do we have the right history? And do we have the right people who are trained to maintain this equipment? If you have all that and you're looking for ways to amp it up, then there are lots of the controls companies are looking into AI. I use AI right now for it sounds like basic stuff, but they're hard to do. Like, I use it to do documentation. I get it to improve, like, say, oh, I'm trying to do a procedure or a policy or a work instruction for this process. I write it out in my terrible, I'm not the best writer in the world. I try to write something down that's okay. And I say, can you improve upon this? And it'll rewrite it for me in a way that's a little cleaner without all my bad sentences and stuff. So I find AI makes me a better writer. So I use it for these kinds of things, and I use it for ideas. But for getting it into the control loop, I see a lot of factories we work in are just not there yet, but everyone is dabbling in it to see what it can do. But I think we're really only at the front door of what it's going to become. I think it's going to be quite a few years before that you start seeing if it actually even works, if it comes into play.
Speaking of dabbling, let me ask you to dabble into your predictions or premonitions. What should engineers expect in the future? I mean, whether we're talking about predictive or preventive maintenance or something else, what are some future trends? Just looking ahead 1 or 2 years, I'd say.
I'd say the future trends in the short run is just better, more accurate, and smarter sensors, and better and smarter control equipment. So if you have a factory that you haven't upgraded in the last 10 years or more, you're gonna be seeing things like the Internet of Things. Obviously, that's a buzzword from a while ago, but really getting everything online and having proper logging and reporting on what's going on and reporting on what matters. If that Before you can really advance anywhere, that foundation needs to be set. So a lot of factories are running on, say, we work in some plants and everyone's running the Rockwell PLC 5, and that stuff's just not made anymore, or it's barely supported. And sooner or later, it's not going to be supported, and everyone needs to do a major upgrade. So they're going to have to do a big jump to the more common PLCs now. The other thing that's going to be coming is you hear about this more and more every day, is with getting everything online, the result is cybersecurity problems. So you have these, and I think everyone should, if they haven't thought about this, is the days of the hacker that comes in your computer and makes your screen look funny or corrupts your data. Those are yesterday's hackers. The hackers of today, they don't ever want you to know they're there. You'll never know they're there. They're just there watching, collecting information, and looking for opportunities to infiltrate, but they really don't want you there. And if they're those the ransomware type folk, I think those are sort of a tier two. They're just one rung up from the classic hacker. I mean, once they ransom you, they've made you aware they're there. Now they're in, so the cat's out of the bag. And if they found a tricky way to get in there and get 30 million out of the company or something like that, everyone knows, or not everyone knows, but there's a trend that even if you pay them, you can't get your data back. So there's a trend towards not even paying out and just trying to back your system up. So really the great hackers are in there and you don't even know they're there. So that's the scary side. But the positive side is everyone needs to have a good cybersecurity program. So if you're a plant operator and you're not up on cybersecurity or the risks or how to manage your OT or IT system, that training is something that's got to happen. And then on top of that is because of everything's online, you have access to big data. So understanding how to analyze and work with big data sets and using the tools out there that can allow you to look at long-term trends and allow the AI and machine learning tools to take the past so they can predict the future for your systems. That's going to start coming into play. And the last is that I've seen a fair bit of is this AR and virtual reality stuff. I'm not a fan of the VR, but the AR is really cool. We've seen plants where people come in and you do this LiDAR, which is a light scanning system, and you can scan your entire factory floor and then convert that to a drawing. So when you do like actual dimensioned drawings, so that because lots of times these facilities don't have great drawing sets, or they're really hard to work with. Well, you can walk through with a LiDAR and do an entire LiDAR of your whole factory, and then it's to scale. And then if you're doing planning a major capital project, you have a dimension drawing that you can plan where you're going to put things, how are you going to get things in and out, and if you have to blow out a wall, how that's actually going to happen. And you don't need to redraw everything in 3D models because it already exists. So that's something that exists today, and you'll see more and more of if you need it.
Well, that's a lot to think about, Michael.
Yeah,
lot to think about.
It's a lot going on. There's a lot changing, but really it's sensors, cybersecurity, and smarter systems. And like I said, it's not a job killing thing. It's an enabling tools so that we as plant operations people and capital projects people can get our projects budgeted for. You can go to your bosses now and say, here's the advantage of it. Here's the trends I see. This is the value this will bring you. So you can become more part of the value chain. And also you can just do your job better because it gives you more information to make better decisions.
All right. Well, that was Michael Wrinch, the founder of Hedgehog Technologies, talking about several different topics related to maintenance, some of which may help you decide to do things a little bit differently. So thank you so much, Michael. It was an absolute pleasure to chat with you.
Well, you're very welcome. And I hope that the wandering all over the topic and was able to help you and the folks out there get some good ideas on how they can consider how to maintain their plants.
Definitely, definitely. So for more information on maintaining your plant floor edge, maintenance, or other manufacturing related topics, visit Plant Engineering at www.plantengineering.com. Thank you so much for joining us today, and goodbye.